Thank you so much for joining our session today. Welcome to our webinar related to about how to write a great research article and get it accepted by a good journal. My name is Tatiana Castro. I am the customer consultant for the Caribbean region. I just want to introduce to the public my colleague Anthony Newman, who is presenting today. Anthony is a senior editor at Elsevier based in Amsterdam. He currently works as a Flex publisher, managing several journal groups. Over the previous 20 years, has been responsible for 19 laboratory medicine and biochemistry journals. He joined Elsevier 35 years ago and has been an editor for the last 25 years. I think I have a background noise. I don't know. Perfect. Thank you so much. And prior to that, he was marketing communications manager for Elsevier Biochemistry Journal. He's a polymer chemist by training and was active in industry before leaving London for Amsterdam in 1987 to join Elsevier. Welcome, Anthony, and thank you for joining today. I think you can I think you can unmute yourself. Please let me know.
I can unmute myself.
Perfect.
I'm now going to share my screen, which is the game plan on a good day. Right. You got that, people?
Yes, we do.
Great. That's a good start, isn't it? It's nice when the technology works. Thank you for inviting me, and I will be in this short hour just working with you with a few tips and tricks to make hopefully your life easier, because if you can publish your research, then things happen better than if you can't publish your research. That's the reality. So there's a whole bunch of material here. Afterwards, the whole slide set will be available from the conference, no problems. That's important because there's so much material. I don't want you to be taking notes or recording it or scribbling down URLs or whatever. That's a bit too silly. So basically what we're trying to do in this workshop, we assume that some of you are amazing scientists publishing great papers. Some of you are great scientists, researchers, not yet publishing enough. Some of you are still working on your first articles, and everything in between, the whole spectrum. We need to know the best way to publish because it's getting tougher and tougher and tougher. And so therefore, what we're trying to do as a publisher is just to share a few ideas with you. So here's what we're looking at. Seeing what's going on. It's not a black box, teaching how it happens. What you need to do before you start writing, what's the best idea of choosing the right journal, what your rights are, what your responsibilities are, areas that you might get wrong if you're not careful, like plagiarism, making sure that you understand that, and also a little bit about how peer review works and how you may benefit by being a referee in the future. So that's the basic idea. So there's lots and lots of journals out there. In terms of STM journals, scientific, technical, medical journals, there are an awful lot of journals, 28,000 at least, about 2,000 plus publishing houses, and about 2 million articles a year. That means all the researchers in the world are publishing this sort of number of articles. They've all got to go somewhere, and so they go into the journals normally that the authors choose, or sometimes it's their second or third choice, but it's normally the author or the group of authors' choice where you publish. And so the publishing houses are not just creating journals for nothing. We are creating journals where we think there's a need for them, because launching journals are very expensive, and so therefore we want to make sure that there are enough people who will read it and will submit to it and so on. So why are you going to publish? Well, quite honestly, you might have done the research, but if you haven't published, well, no one believes you've done the research. So publishing is your proof that you've done the research. You might have a personal reason, of course, but the reality is you've got to think about the needs of the readers, not your needs. because what's in it for them? That's what it boils down to. Can you help them with any problems they've got? Is there a new method you've developed? Is there a new insight into a particular thing you've discovered or you think you've discovered? That's the sort of thing you've got to be thinking about, the needs of the reader. And what are you going to publish? Of course, the new material, new results, new methods, and reviews or summaries, something that advances the field. You can publish Me Too papers, so-called sound science papers. It's far better and much more interesting to the reader if you can produce and publish novel, original material. So before you start a course, you've got to be thinking about what's out there. You can look online, you can use things like Google, but it's better to use something else, something that's a bit more detailed, things like, say, Scopus or Web of Science or even Google Scholar. The idea being just to find out what's out there and what you need to know about. If you're researching something, you need to know who has published recently in your field, because you might need to know that information and to cite that paper or papers. Or even worse, the last thing you want to do is to finish your paper, about to submit it, and find out that someone has published almost identical paper than yours 3 months earlier. So it's good to keep on searching what's out there, have a search profile, a search string, register it at the various abstracting services, and then rerun the search every so often. And that's a clever way to do these things. There's all sorts of things you can use. Depends what app you've got access to. The important thing is always assume that once you've started researching, you should not stop searching. You still need to know what's out there the whole time. If you have published previous papers, that's great. If you published papers a long time back, you're also going to make sure your references are the best they can be for the reader. What's the latest research out there you think the reader should know about in your references? So before you think about writing, you have to say, well, why are we going to do this? Because I have to. It's the wrong answer. It's more, what have I researched? What's interesting? Is it new? Is it hot? Is it giving a solution to perhaps a method problem or something? Is everything ready? Do you have enough material to give a comprehensive, clear story? If you are writing with other authors, co-authors, discuss these things, because you don't want to wait until your paper's perfect, because that might take 5 years or 10 years. But at the same time, you don't want to publish it with big holes in it, where you need to then go back and do more experiments or more studies because the referees find that you have not given enough information. So that's a discussion you need to have either with your colleagues or with your supervisor to make sure you've got enough information ready to publish. Then you start thinking about preparing. So here's a way of seeing it also. Are you ready? Are you not ready? And so therefore, if you are ready, great, that's the idea. And then you've got to think about, do all your co-authors agree you're ready? Because it's a group agreement. It's not one person muscling through their thought process and basically, sort of pushing things through. There has to be some sort of agreement there. You're co-authors because you're co-researchers. And you've got to have a strong manuscript, because a strong manuscript is a way to get your research out there. If you've got great research and you've got a poorly written manuscript, what a waste of your wonderful research. If you've got a great research article structure, well written, but almost nothing in it because it's empty, it's also a waste. You've got to have that combination. It's far more difficult to get published now than it used to be. Some of the silverbacks out there might be saying, oh, it's easy to publish. 20 years ago, it was easy. Yes, it was easy 20 years ago when you were still learning these things. And there, the acceptance rate was about 70%. Now the acceptance rate is around 30%. And so therefore, there's far more competition to get published. And the silverback from 20 years ago has actually got better and better at writing in that meantime, so they haven't noticed any problems. Everyone else has, of course. So, but your research paper has to be novel, not repeating something else, clear, understandable by the reader. useful, has some practicality, and also some excitement, not boring. Now, we all know scientists in general, we're boring people, but your message should be very exciting. That's the important thing. And also you've got to present it in a logical way, not a chronological way, but a logical way, because you've done experiments or research or studies in a very, very time process way. That's your chronological way. But if you're explaining it to someone else as to what's interesting, you don't want that. You're not reading in a diary. You actually want to do it in a logical way, and that's the important thing. And so also when you are writing, you've got to make sure that any significance you've got is easy to find. It's in your abstract, it's in your discussion, it's in your conclusion, because you can't think, oh, they'll notice. They'll notice. They'll find that figure B, that interesting little graph there. They might not. And so you really got to be explicit in what's in your paper, not implicit. And that's something that scientists are not really good at. So you really got to get good at that. And also recognize that editors and reviewers are busy people and may not give your paper very long before they decide it's not good enough. So therefore, it really has to be pretty top-notch when you send it in to make it useful and hopefully going out for peer review. More of that later. So now you've got to think about the right journal. What are you going to do? Are you going to use, what sort of journal are you going to use? Are you going to send it to a journal you like, possibly? Are you going to send it to a journal where it's a top quality journal, but you might get in, but it's high impact factor? No, it's the wrong way of thinking about it. You should be thinking about, where does the reader expect to find your research? That's a better way of doing it. You've got to think about all the various things that are out there, and where would the reader expect to find you? Where would they feel comfortable reading your article? What's their comfort zone journal? So you've got to look at all the various journals you want to possibly go for, and all the co-authors might have good ideas, and some might have published somewhere else and like the service they got from that journal and so on. You're also looking at all the various references you have, because that will also help you to maybe find a particular potential journal. So you've got candidate journals. So you're looking at, say, Ames and Scope, sort of articles that they're publishing, who's reading it, guide to authors, are there word limits or whatever. And then, so that's a useful thing to do as an exercise as a group between you and your co-authors. And say, look at the references, that's quite helpful. And for each candidate journal, you can ask yourself, well, who is the readership? So you look, are there papers like yours in that journal? How fast is the journal? That's also important, because some journals are very, very slow, and you might get overtaken by someone else publishing almost the same thing who published in a fast journal. In terms of patents, your journal article might be first because it was submitted first, but in terms of impact on the community, it's whoever published first, appears first, actually gets the visibility. You've got various impact metrics, of course. You've got things like the impact factor, the science score, all sorts of different bits and pieces. In fact, there's so much bibliometrics out there that this whole website's based on that. Do you need to publish open access? Another aspect. If your university insists you publish open access, or your funding body, make sure it's a real journal. There are some dubious open access journals out there, unfortunately. Again, the librarian's helpful in this sort of thing. So they're your ally in finding a good journal. So have a look at the journal homepages, go to the guide to authors, see what they want. That's why you're doing all of this before you start writing. What happens if you write a great article, manuscript, and then you come to find a journal you want, and you find that you're 5,000 words over what they want. And so therefore, it's far better to start from what they want and then start writing than do it the other way around, or else you're just going to desk reject. And also, of course, the guide to authors gives the aims and scope of each journal. You're going to make sure you send your article into a journal so that you do not want to get an out of scope desk reject. That would be a waste of your time. And of course, a waste of the editor's time too. This is a journal matching tool we have. It's interesting to play around with and just see what comes, because by putting in your paper's title and abstract and keywords, you can see what sort of journals the AI system here thinks might be interesting to you. You can have a look yourself and find out. As I said, bibliometrics, all sorts of various things are here. The SNP and the SJR and so on, SciScore. And if you want to go further into this, just type bibliometric indicators into Google Scholar, and you get an awful lot, or Wikipedia even, an awful lot. And so you and your colleagues have come up with a list of journals, say 5 journals, and then you all agree which journals they're going to be. And then you also got to decide the sequence you're going to submit. You hope, you really, really hope that your journal will only be the first journal you choose to be the one that accepts you, but at the same time you want to have a whole list of up to 5 just in case. And then also you agree the sequence you're going to submit to. You're not going to submit to all 5 at once. That's called parallel submission. It's noticed, and many journals will ban you for 2 years if they spot you are duplicate submitting. So it's just not worth it. So you agree who's going to be, what's going to be the first journal, and then the lead author, whatever it's going to be, normally the first author, sometimes it's the corresponding author, the last author, but they decide who's going to draft it, who's going to go further forward. You read the guide to authors, and then you go on with that. And then you got to work out, how do I structure it? Now, some journals are very clear. They say you must do it this way for our journal. Others are not clear, and they say, well, actually, you need to do it a bit differently. You need to do this and that. What you should do is look at the journal of choice, read many articles, see if there's a theme, and so it gives you an idea of what sort of structure that journal finds acceptable. That's a good idea, So you just do it by copying someone else's structure. But if they don't tell you, and there's all sorts of different structures within a journal, and I've got a few tips in a minute. But the important thing for when you're writing is short sentences, very short, not long sentences. I know some cultures say, if I can write one sentence of the whole paragraph, I'm elegant. Maybe in literature, but not in science. So it's one piece of information per sentence, short and snappy. And that's very important. Now, here's a structure of a research article, typically. So it's split into 3 bits: a title, abstracts, keywords, which is everywhere, it's visible, the main text, the introduction, methods, results, discussion, and the tail bit, conclusion, acknowledgements, and so on. Of course, reviews and micro articles are different. This is typically for say a life sciences or health sciences type article, but for social sciences, it's much more discussion and far less data. And what's the fish doing there? Well, the fish is symbolizing what the article is in terms of its structure. It's a head, a body, and a tail. So that's how you'd lay out the research article, but it's not how you'd write it. How you'd write it is very different. You think about building a wall, and also it helps stop you getting into a brain freeze. You do one thing at a time. And so you start with figures and tables, and that makes you feel okay. It's your comfort zone. And then you put your methods, results, discussion, and so on. And then, of course, keywords in there somewhere. So that, like building a wall, is far easier. Once you've done that, you deconstruct it and lay it out from wall style into fish style. If you have written lots of papers and have not tried this process of constructing your article, try this way, the wall style, moving into the fish style. I think you might find it's easier for you to get your paper finished in a polished way. You don't have to, but I tell you, I wish that I had learned about the fish in the wall when I was at university to start off with. But there you have it. A few years too late to learn about these things for me. So going through, yeah, is someone talking? Someone needs to mute maybe. So what we have here is a title. I'm going to go through all the rest of things fish style, and that will be a good way to explain in a clear way what you should be doing. So first, the title, as short and snappy as you can make it. It should begin with the subject of what your research is about, because people will be skimming through a list of titles, and your title has to stand out. Therefore, the first few words should be what it's all about, not the end of the title, but the beginning of the title. Again, as short and catchy as you can make it, but at the same time, it must be reasonably clear. That's a difficulty. It really is, you know. So after the title, of course, the abstract is job. If you're a reader, you read the title, you can jump into the abstract, and then you look, is this what I want to see? Yes or no? And if it is what you want to see, that's great. The abstract's job is to tell the reader what you did, and if it's useful for them to read on. So this is, some journals are pretty cruel, they say 50 words, but in general, it's a paragraph. And if you're allowed to do highlight bullet points, even better. If you're allowed to do things like a graphical abstract, even better still. It depends on what the journal will let you do. And remember that the referees normally are giving you the title and the abstract, and depending on the field, sometimes your information too, your institute, your names, to decide whether they want to review your paper or not. They're not given the whole paper, just the abstract and title to see if they want to review your paper. So therefore, this is important because the abstract's job is to get interested people to agree to referee your work, which means it gets faster through the whole process. So here's a simple example. It happens to be chemistry, but here's what we did, here's what we found. Basically, as simple as that. You know. Now, with the results, the difficulty with junior researchers is they try and share too much material. And they say, well, here's what we found, blam, the whole lot. That's no good. It drowns out the reader. So you've got to only share the main findings, the interesting findings. And top right-hand corner, you got a picture of an iceberg. An iceberg, most of it's underwater and only a little bits above water. You've got to decide as a researcher what bits you're going to share with the reader, what bits will remain underwater. Not because you're hiding them, but because they happen to be just duplicating other work. So therefore, you're sharing just the important things and make sure that the results you're sharing match your methods you're describing as well. There mustn't be different ones. If you find anything different, that's unexplained, that's fine, that's good, because that means you've actually made sure you actually can replicate it, make sure it's not an artifact, and then that's how science moves forward, by finding things that are unexpected. And of course, make sure that your stats are correct. If you're not sure using the right stats package, then ask someone at your university to help you out there. If you can, use illustrations, use figures. Why? For two reasons. Firstly, the reader absorbs your information better. And secondly, if you do a good figure, a figure legend, you don't need to write about it in the text. There's less writing for you, less reading for the reader, and the reader absorbs the data better if it's in a good figure. So that's why we should do as many good, clear figures as you can. Of course, they have to be clear figures. That does mean that these three examples, on the right, of course, is please, it should always be in English, not some other language. If you happen to buy a trilingual, it's fine for local presentations. But when you're submitting international journals, please in the language that the journal wants. If you need to put some, say, the central panel here, you need to put some little arrows, make it clearer for the reader what's going on. You can do that, as well as doing it in the figure legend. It just makes it easier and clearer for the reader, the needs of the reader. And thirdly, we've got blue and pink. Now this looks great as it is. You print it out in black and white, it looks grey and grey. So from that point of view, you're forcing the reader to go and find a color printer. If you'd done, say, triangles and squares or stars and blocks or something instead, then you'd find it far better and clearer. So no need to find a color printer. Of course, your article has to have references. And it's also, if you've got an article in a drawer somewhere and it's been lying around and you think, oh, I must polish that sometime. You dig it out, dust it off, go in and find some more modern references, because the first thing an editor will do, they'll look at the article and see two things. Firstly, are there any references to this particular journal you're submitting to? Are there any references to journals in the same field? And what is the date of the latest reference? That is the basic criteria. That just tells you where they're coming from. It makes sense. If you have not referenced any journals in the field you're active in, and in the field this journal is active in, why are you submitting to this journal? So that's their viewpoint, because if you're not citing any journals in your particular field, whichever field this journal is, then there's something wrong somewhere. You should be choosing another journal. But also the references have to be laid out properly. Now, you might use something like EndNote, RefWorks, or whatever, depends what your university is using. Often they buy a subscription to one of these things and you can use it for free. It's not free, but it's free to you. Mendeley, for example, is free for everyone, everywhere. There's no cost at all to that one. And Zotero is another similar one, which is a free service. So it's good to put your references into some reference management software, because if you change from your first choice of journal to a second choice and they got a different reference style, you just re-export the new style. You don't have to reformat the whole thing. So that's a very useful way to save yourself energy. And you've also stored references for the future. So from that point of view, it's worthwhile investing, entering up the references into some system. Because if you don't, and you're going to type them over every time, the chance of errors is very high. Also, make sure that the author's names are spelt properly. If you spelt it wrongly, or if you spelt the journal name wrongly, or the actual number of pages or volumes or whatever, big journals do check the references, small journals do not. And so if you are sending it to a small journal and they don't check the references, then if that article gets published by you, those references you've given, which are incorrect in terms of the typos or something, those authors will not get any citations. You cheated them out of a citation because you haven't actually done it properly. You've given them the credit by repeating the reference, but they won't get a reference so centrally. They won't get the benefit because you haven't done it properly. It's your responsibility, not the journal's. And so you can say, okay, well, we're getting there. Typically, a submission is written and rewritten 2, 3, 4 times. All the various people look at it, the co-authors and everyone else. Each time you look at it, you polish it a bit more. Do not think, I'll wait until the revised version to polish it. No, you've got to make sure it's polished in the first version just in case it gets accepted as is. Don't rush. Make sure all the co-authors really do approve it. You can't say, here's what it is, guys, I just sent it in. No, it's here's what I'm thinking of sending in. What do you think? And then when everyone is happy with it, in as the co-authors, then what you've got to do is say, okay, then now's the point to submit the article. So you've done all the various work in the past. You've made sure all the references are there. You're sending it to the right journal, you hope. All the co-authors agree with what's in there. So that's a good point to literally push the button saying submit. Now, most people regard that as a black box, but it isn't, but it seems that way. Some people say to me, is it worthwhile doing a covering letter? It is. It's like sending in a manuscript. It's like saying, here's my CV, and then sending it into a company. Whereas what you really want to say is, here's my CV and here's the job I'm applying for. Same thing here. Here's my article and here's why I think it's good for your journal. And so typically you'll be having some sort of thing about why you think it's a useful article to have in a person's journal. Also, you've got to say why this scientific work is important for that particular journal. If the journal has not asked you to suggest referees in the submission system, there are still publishing houses that don't do that. You can suggest it in the cover letter. So all those things are there. It's just a question of getting on with it. You can choose not to send a cover letter, but it's worthwhile doing it. If you do send a cover letter, remember, if you are sending into a second journal, because the first one declined you, update your cover letter, or else it looks a bit silly. And they'll know that they're not the first choice, but second choice. And that doesn't put them in a good mood, okay? So only the handling editor sees it. It doesn't get published. It doesn't go anywhere else. And yeah, make sure it's there. And it's just simple. No weird and wonderful things on it. Not too long. Just a simple one side of paper, and then maximum. And then it helps the handling editor look at your manuscript and letter combination. For authors, who are authors? Well, your co-researchers are authors, you'd expect, but it varies a bit. But in general, the normal process is that the International Committee of Medical Journal Editors, they're called the Vancouver Group because they first met there. They say everyone who's an author has had to substantially contribute to concept design, acquisition, and so on. Has to be involved with drafting the article or revising it in a very important way, also to improve the final version. They can't just, for example, be added as a co-author because they've polished your revision. That's not it. And also, all authors have to agree to be accountable for all aspects of the work. Now, there's also something new that's coming along, is that we have the credit system, whereby there's almost a list of various aspects of the paper, and all the various people or co-authors, their names are listed against various aspects. So that's the bottom of the article, similar to acknowledgements. So that is coming through. It started in health sciences and it's gone into life sciences and physical sciences, and it's coming into social sciences now as well. So it's slowly spreading across. So I would guess within 3 to 4 years, every journal will be asking for a credit statement. And if you're not sure about that, just go search online, you'll see exactly what it involves. So here's a few bits and pieces. Oh, of course, if you are first author, co-author, whatever, the sequence of authors varies a bit. If you are in every field except for physics, then it's very important who's the first author and who's the last author. But if you're not in physics, yeah, but if you're in physics, it's alphabetical, simple as that. But the first author is the person who's done most of the work. And they're the first author on the paper, and that's fine. And they normally are the one pulling it all together. They submit the article. The co-authors are there, and they are in various sequences, doesn't really matter. You can agree amongst yourselves who's number 2, who's number 3, number 4. Sometimes you can have co-first authors. So you put a little asterisk after the first name, second name, and a footnote which says, please note, both first author and second author contributed equally to this paper. Happens occasionally, but it can be done. And what you shouldn't be doing, of course, is leaving out people. They're called ghost authors. People who might have left the lab after the experiment has started, and you forgot to include them. And also people who you decide just should be added just because they've given you some kit or they've polished your article or something. That's not what it's about at all. That's an abuse. When you do decide to send in your paper to peer review is the best thing we've got so far, but it does seem a little bit cruel. Now, this is a wonderful cartoon. I hope you enjoy it. This is a guy called Nick Kim. He's a biologist in New Zealand, and he does scientific cartoons, which are copyright free as long as you don't change them. So it's not changed. But this is what it seems like. You, the scientist, going towards paper accepted goal, and you thought colleagues suddenly pick up axes and knives and a chainsaw, and of course the Grim Reaper at the end, just to try and stop you getting your paper accepted. It seems that way, but it's not like that. What's happening in peer review is they're trying to make your paper better. It might not seem that way, but that's what happens. So this is actually the process where you push submit. You might not realize it, but what you've got is you've got the peer review process. It starts off, you submit the paper, there's a dotted line there. Before it gets to the editor, someone checks to make sure everything's there. Are the various number of figures all there and the figure captions? Is the conflict of interest statement completed? Are all the other bits and pieces done? If that's the case, it goes to the editor. Editor then says, okay, is this of interest to me in my journal? Yes. Okay. Well, no. It might be, this is awful English, it's terrible. I don't understand it. That's a desk reject. Or it could be, but we changed our scope of the journal 4 years ago. Didn't they look at the latest scope? Out of scope, reject. Or it could be it's a clinical trial with 3 patients. That's useless. It's not enough. So reject. So from that point of view, the editor's job is to do the so-called desk rejects. Why? They do not want to send junk, in their minds junk, out to referees who are busy people also. They only want to send out things they think might be possibly acceptable. So they decide which papers to send out. They then try and decide who are the best people to send them out to, and they do. And then they ask 2 people, sometimes 3, but normally 2 or 3. And then those reviewers will either say, yes, they'll do it, or they will say they won't do it, or they will time out. Or they'll say, I'm sorry, I'm busy, but I suggest you go to Dr. X instead. And so then you've got 2 reviewers, and the reviewers then have typically 2 weeks, if it's social sciences, 4 weeks, to come back with the various comments about the paper. The reviewers do not decide. They only recommend what they think is appropriate. And so the editor gets back the recommendations. If one is, for example, way out, as reject is awful, one is amazing, accept as is, then obviously you need a tie break in there. So either the editor will read the paper herself, or alternatively, the editor will ask a 3rd person, perhaps one person from the editorial board, to come and comment on this as well, to help the editor make her decision. And then when she has the various recommendations, she then makes a decision, which is accept or reject or revise. That is the workflow of what happens when you push submit. And that can take anything from 2 days, a day is a desk reject, all the way through to 8 weeks, 10 weeks sometimes, all the way through to that final comment by the editor as what's happening. Accepted as is, very, very, very rare. In my field, life sciences, it's 1 in 200 papers. So, so you might have a paper accepted as is with no changes whatsoever. And then, of course, the next paper you send in gets a desk reject. And that little cartoon there is so abject depression. And that basically, that's what you feel. You know, everyone gets rejected, even Nobel laureates. Try and understand why. Did the referees have some interesting comments? So what happens is when you do get the comments back, and is it rejected or not, then carefully read through the comments from the journal. It might say, we cannot accept your article as it is. And then you read through it, it says, do this, and maybe we will. That's called a reject with hope. But it might be they're also saying, there's so many flaws in this article, and here's all the rest flaws we think, so go away. Okay, that's very, very clear, but make sure you and your co-authors read this. It's often so easy to misinterpret what they say. So always get another pair of eyes on this comments from the editor. And if they do say go away, all right, they say go away. So then you take advantage of all the referees' comments, revise the paper, go to Journal B, remember Journal A, B, C, D, E, read the guide to authors, reformat if you need to, do a new cover letter, off you go. You've used the benefits of the referees of Journal A to hopefully help you get accepted into Journal B. If it's a revision, then it means it goes back to the author, and the author either has to do a minor revision or a major revision. It's minor, they hope you'll get it fixed, and that goes back to the editor typically, and they see, has the author done all the various things necessary? Yeah, okay, fine. If it's a major revision, then they tend to send it back out to the reviewers saying, hey, reviewers, you were concerned about this. Are all the various points made? Have they done something useful here? Sometimes you'll even get a major revision followed by a minor revision. That sometimes happens. That just spells out what happens. The major revision, it goes back to the referees normally, and a minor, doesn't guarantee acceptance. It's pretty close, as long as you address all the things that you need to do. And what you do, of course, when you revise a manuscript, you tell the editor what you've done. You say, each reviewer's comment, you say, okay, reviewer 1, that's point A, B, C, D, E. You do cut and paste. And then you put your comments after each of them. And then that makes it easier for the editor to understand what you've done. If you just say, thank you for the comments, I fixed it all, that's useless. They hate that. That means that they got to somehow go through and see what you've changed. And that's not what it's about. They're more likely to reject you than to try and do that. So some journals even ask you to do two versions, a marked up version to see what you've changed and a clean version. Others ask you to add page numbers, line numbers, or whatever. It varies. Read what the editors want you to do when they write back to you. If you don't like a particular comment and you and all the co-authors agree, this is a stupid thing the referee said, you do not write back and say, this is stupid, referee A.5. You say, well, referee A.5, we as authors disagree with, and we think that our comments should stay as they are. Perhaps that particular referee hadn't seen this recent reference, blah, blah, blah. And so that's called a rebuttal. And it's up to the editor to decide, based on your text and your rebuttal, whether she'll go with that comment or not. If she does go with your rebuttal, that means that text stays forever. It's great, you've won. And also that referee normally gets a copy of that rebuttal so they know what's happened. So it's good for you to be aware of that. So, and also when you do revise a manuscript, make sure it's well polished. You've polished the first version. If you just toss in a few words here and there, but don't polish it, it looks like that. The editor knows it looks like that, and so therefore they're not going to accept it. So always, when you have added the extra text, polish it up, make it as good as it can be. In theory, this is what's going to be in the record of science for longer than you're alive. So spend time on it, you know. So it's not rocket science. Huh? You've got to be consistent. You've got to check and recheck before submitting. Make sure you're telling a logical, clear story. So a little line running through it of logic. And say not chronological, but logical. And of course, when you are looking at improving your paper, see what the referees have said, and they'll help your paper get better and better. They don't even want to be a co-author, they just want to help you get published, which means that's great. You get more downloads and more citations because of their care in commenting about your science. So that should mean, of course, that you are more likely to be accepted rather than rejected. That's just the name of the game, the idea, isn't it? Now, the other aspect of publishing, whether we like it or not, is publication ethics. We've got lots of rights, we've got lots of privileges, but we've also got to be ethical. The major things that turn up are fabrication, it's making up the data, manipulating existing data, falsification, or taking work of someone else and passing it off as your own. Or even you can take your own work and just republish it without citing your previous reference. So basically that's self-plagiarism. It's not really the idea either. They're not good things. So the idea of science is evidence will be based on someone else's concept, and then you work on that. So therefore you've got to give those scientists, those researchers, the credit by giving them the reference. That's how it works. Standing on the shoulders of giants. So if you do get caught plagiarizing, it varies. Some scientific journals will ban you for a while. Some universities will stop your, terminate your employment. Some scientific communities will just ban you from applying for funding. So it's not a light thing to do. So you've actually got to make sure that it's done carefully. Now, how do you make sure that you don't plagiarize accidentally? That's a difficult thing. If you've got 4 co-authors all working on text and you're looking at various other articles and you put the reference into the body of the text and some text in there next to it, have you remembered to proofs on whether you actually really, it's your text or the text of that particular author you're citing? If you're not sure, the best thing to do is, as you're entering it into the draft manuscript, put speech marks around the text you brought out of that particular paper you're citing. So you've got speech marks, text, and a reference. It's up to you whether you rewrite that text but keep the reference, or whether you leave the speech marks in. But by leaving the speech marks in, you know it needs working on, or leaving as it is. Otherwise, you could be accidentally plagiarizing someone else, which you don't want to do. So duplicate publication is self-plagiarism. In these days, everything's electronic. You don't need to publish more than once. Once is enough. It's findable. If you need to republish because it's another language, you can. There's certain ways you can do that. All sorts of weird and wonderful things you need to do. Get approval of the previous journal and the copyright holder, everything else. And so the important thing is, if you have published something in the past and you are referring to it in your paper, you must cite it. You might think, well, I don't want to cite all 8 of my previous articles because it looks like I'm boasting. Doesn't matter. If you've taken bits out of each of those, you must cite them, or else someone might think that you are trying to cheat and you're trying to get an extra citation because you didn't quote that other article you missed off, as it were. Now, we used to do random checks of plagiarism, but it got so bad that now every single article is checked using Authenticate, which in effect is the same as Turnitin, but it's cross-check, call it what you want. And that takes around 12 to 15 minutes per submitted article to check through millions and millions and millions of other articles looking for similarity. And what happens is when the journal editor opens up the submitted article, next to it is a plagiarism score. As a percent, they can click on that and see which words or phrases come from somewhere else. And so that's needed to be done. So it's a sort of sad reality. It's less plagiarism now that every major publishing house is checking everything. It shouldn't have needed to get that far, but it did, unfortunately. This is an old example, very old, but at the same time, it's from the days when we didn't check everything just randomly when we had a few complaints. So we had complaints and we checked, and with Authenticate, it color codes things. So the same color is the same text, identical. So you can see that on 2003, you had this Elsevier article. You see the tree there, the Elsevier tree. So the yellow on the left is the same as the yellow on the right, an article in another journal. The blue on the left is the same as the blue on the right. The green on the left, same as the green on the right. The orange, the same, orange. And the sort of the purple, the same. The figure they got from somewhere else. So basically, this is what I would call a Control-C, Control-V paper, cut and paste, just created out of nothing. And in the past, people got away with that. And when they did get away with it, or when it was discovered, then the publisher took it down electronically. And the National Library of Medicine said, you can't do that anymore. You've got to leave it up and put a watermark across there. Otherwise, it's the same as you creeping into every library in the world with a razor blade and cutting it out of that journal. So no, you've got to change it. So we did, we changed it. You know. So on the PDF, it says retracted, and in the HTML version, it says why. And that's up forever. Not useful if that particular researcher wants to continue researching and continue applying for funds and everything else. Now for figures, there is now figure checking software, which works quite well. We're just trialing it for more journals than we used to do. So you're allowed to do certain things. Thumbs up, you can do certain things. Thumbs down, you can't do certain things. So you can change the brightness, the contrast, the color balance, and nonlinear adjustments as long as you mention it in the figure legend. In fact, some journals even say if you change any of the figure characteristics, the original unchanged figure must be put in a supplementary file as an original figure, just so the readers can compare if need be, in case you were too enthusiastic with your controls. What you must not do is enhance, obscure, move, remove, or add things. So that's a simple thing, really. This is where one went badly wrong. This is a great article, American Journal of Pathology 2001, about some interesting stuff. It's as you can see, if you don't know, it's fluorescent cell staining. And then some people, I won't call them scientists, some people took this, added a few spots here, a few spots there, wound up the color contrast, flipped it round, and published it on another topic entirely in a journal called Life Sciences in 2004. Now you can't see this figure as it is, because when you go look in that journal, you've got a big watermark across it saying retracted. So yeah, these things happen. So what you've got to think out, okay, learning tools, tips and tricks. Do you know what's going on now a bit more? I hope so. Do you know to think about what the reader needs, not what you need? Discuss things with your co-authors. Make sure you've got the right co-authors, no extra ones added just by mistake or because they elbowed their way in. Make sure you're not duplicate publishing. And also think about perhaps becoming a referee. Because if you can become a referee, then you can start to see really mistakes other authors make. And it makes you a better author, and also you're contributing more. There's a whole bunch of slides which I didn't have time to present, so they've been suppressed. So when you get the PDF, you'll find extra slides. But there's a great resource that we have created a few years ago, and it's used by hundreds of thousands of people within the scientific community, called Researcher Academy. It's all free. Just register and see what's in there. There's a few articles, a few recordings, a few webinars, yeah, all sorts of different useful things. Also, even not just writing, but also things like how you can get your funding application and so on. And of course, your university library, they're useful people. They know, I understand bibliometrics. Go talk to them. Not enough people go to the library and actually go talk, and it's worthwhile doing, you know. Do you need to know things like time to first decision? Is a journal in Scopus? Ask these questions, they'll know. In terms of writing courses, some graduate schools help, some don't. Some universities assume that you'll absorb everything like osmosis. No, that's why we're doing these workshops, to help people. If you can find someone who's a journal editor or a board member on campus, go talk to them, just not stalk them, just go talk to them and say, hi, perhaps you can help me here, I've got a question about submitting to your journal or not, and so on. And if you are going to publish open access, the rules are changing so fast on a monthly basis that you really need to check out what the current status is and what the current policy of your university is. And again, the library is the place to go for that. So we've still got some time left. What are we? We've been going now about 50 odd minutes, so that's fine. So you're going to get the slide deck, as I said. And so this is my email address. It will be for the next couple of years anyway, till I retire. And then there's a couple of resources, which again, you can go look at, interesting things, and also some further guidance here. And please, when you get the PDF, please share it with everyone, because this is a skill everyone needs to know. And also, one final bit of information is there's a certificate of attendance you can get by using the QR code here. So these are all the various bits and pieces. So what I'm going to do now is stop sharing, and then we're going to see in the 5 minutes or so we have before your lunch, what questions there are. Do you want to say anything to Chiana so far or not?
Thank you, Anthony. Actually, someone shared a tool related to the academic accelerator to provide acceptance, a percentage of the acceptance of the journal. I don't know if you have heard about that too.
Well, where was that? That was somewhere in the
academic
chat.
Accelerator. Someone shared it in the chat. I don't know if you know the tool or if you can.
Academic Accelerator. I've heard of it, yes. And it's they gather information from various publishing houses, which is fine. There's also quite a neat thing that some group is doing. They are offering to peer review people's work and then with that peer-reviewed work, that author then can go and submit it to a journal saying, just to let you know, this has been peer-reviewed by this service, and they find it okay. There's also new services coming up, so we've got lots of interesting things happening here. Let me just sort of zip through some of the things. Academic Accelerate, Mendeley, yeah, okay. Journal, yeah, so you're busy doing things here, okay.
Yeah, I don't know if someone have any questions for Anthony. We have 3 minutes left for our session, so I don't know.
But the next session is a half-hour of lunch, so it depends how hungry people are or whether they want to go into the thing. But I'm happy to answer any questions now, and it's up to the organisers to of the conference to make available the PDF of this slide deck. It was a lot of information I got through. I know, I'm sorry, it was a bit like a sort of train passing through a station, but there's so much material, and I condensed it down to the 1 hour that the conference said I could have. So, nothing?
I don't know if Dr. Peter or Emily have anything.
Is there an online source that lists the impact factors of publications? Yes, there is. Clarivate is the company that generates the impact factors. They're called the JCR, Journal Citation Rankings. And most universities subscribe to the Clarivate service, so they can tell you the impact factors, and they come out once a year, typically around about June, July. Now, in Scopus, we have the site score and the site score tracker. The site score comes out every June. The site score tracker comes out monthly, updated, so you can see how the field is changing, how more citations are coming on that journal on a monthly basis. So that's actually much more dynamic. And many people have access to the Scopus site score. And if you even go to the journal homepage of many journals, they'll have the impact factor and they'll have the site score. So that helps you. Also, it's a useful way, if you've got your few journals you're trying to select, go look at what it says on their journal homepage about site score, time to publication, rejection rate, impact factor, whatever various information they give. Because that bibliometrics is handy for you, and they're offering it as a free service. So use it, basically.
Thank you, Anthony. Well, I think we are on time. So,
okay.
Oh, yes. I have another question. I think it's.
Oh, yes. That's a notice that some journals require payments at submission and other payment when the article is accepted. Yes. There are some journals, particularly in economics, that have what's called a handling charge. And also some societies have a handling charge. And so when you submit it, then that means that it's to try and get people not to submit junk, so they're actually submitting something that's sensible. And then what they do with this money is typically it goes towards, say, Young Investigator Award, or it goes towards the annual meeting of the society or something. So it helps that way. So I don't agree with having a submission charge, but there you are, I'm just me. But many of these society journals or economics journals have this, and they're actually a very structured way of what they do with those funds. The payment when an article is accepted is only if it's open access. If it is not open access, it's a subscription journal, there should be no payments whatsoever, unless you do something silly like asking for color in print, which you shouldn't do. But so if it's a subscription journal, there should be no payments on acceptance. If it's an open access journal and you get accepted, you submit it to an open access journal knowing if you got accepted, there is a fee. Therefore, you've got to pay the fee. It depends who is the co-author, and it could be one of their institutes have a different deal. And so some publishing houses like Elsevier actually do an analysis of all the various co-authors institutes to see the best deal in terms of open access fees. I'm not sure all publishing houses did that. So yeah, it's complicated in open access. I'm sorry, but you don't have to publish open access unless your university or funding body insists. About 80% of all articles out there are published in subscription journals, not open access journals, no matter what the PR says. Okay, so I think why open access journals have rapid impact factor? Open access journals do not have a rapid impact factor. Open access journals get more downloads because they're more visible, but the impact factor is round about the same for the quality of article. I have journals which are open access journals and subscription journals, and they're similar. What you also have to remember, any new journal is not going to get an impact factor for several years because of the way the impact factor is calculated. And so as we have so many new open access journals, they're not going to have impact factors yet. And someone might say, well, why not? Well, you've got to publish 3 years at least, and then they give you the number in the middle of the 4th year. So there's no way you could actually have an impact factor in less than 4 years in any new journal. People have got to realize the mechanism of the bibliometrics. I went off tack there a bit, I'm sorry, but at the same time, it might be helpful. Because sometimes we have people saying, well, why isn't it an impact factor? You launched last year. Well, there won't be for 3 years, 4 years, sorry. Why not? Read how it works. Yeah, okay, we're over time. I'd say you're going to get the slide deck. You've got Tatiana's email address, you've got my email address, you've got all the resources. Happy to help you out. And remember, be patient, be calm, and send in the best work you can each time you submit, because that's the way you'll get accepted. Thank you for your time.
Thank you, Anthony, and thank you everyone for joining the session.